Welcome to qnawire.
Hi everyone, here it is given an aircraft having the mass 300 milligram, that is 3 into 10 to the power 5 kg, having 3 engine, and each can provide thrust of 240 kilonewton, that is 2.4 into 10 to the power 5 Newton. We have to calculate the distance of the runway required for takeoff speed 220 km per hour. First, for uphill takeoff, and second, downhill takeoff. First part, for uphill takeoff, its weight mg will act in this direction. Normal reaction mg cos theta and mg sin theta, and that is the force. So according to free body diagram, you will get 3f minus mg sin of theta is equal to ma. So acceleration you will get g sin of 0.5 plus 3f upon m, because each engine providing f force, the total force will be 3f. Substitute the value. (240), that is 2.4 into 10 to the power 5 into 3 upon mass. Mass is 3 into 10 to the power 5. So it is to be 2.314 meter per second square. Now we know that acceleration is equal to dv upon dt. So from here, dv is equal to a dt. So v minus v naught is equal to a into t, or v is equal to v naught plus at. And distance covered dx upon dt is equal to v naught plus at. So dx is equal to v naught plus at into dt. Now integrating 0 to t, 0 to s. S is equal to v naught t plus half at square. This is initial position and this is final position. Let me correct. Combining 1 and 2, we can write x to be equal to x naught b square minus b naught square upon 2a. So s is equal to 0 plus 220 into 5 by 18 square minus 0 upon 2.314. So it is to be 807 meter. B part for downhill motion. Mg sin 0.5 plus P plus 3F is equal to Ma. So acceleration you will get G sin of 0.5 plus 3F upon M. So you will get acceleration to be 9.8 into sine of 0.5 plus 3 into 2.4 10 to the power 5 upon 3 into 10 to the power 5. So it is to be 2.4856 meter per second square. So S is equal to P square minus B naught square by 2A. This is required is 220 into 5 by 18 square minus 0 upon 2 into 2.4856. So the distance of the runway required in downhill you will get 751 meter. That's all. Thanks for watching it.